Okay, can you hear me now, Gabe?
Yeah.
God, I don't know what it is with this microphone, and it's only Discord. I'm not sure
It's so
why.
weird. Yeah, that's so
Um,
weird, man.
Between Chrome and Discord and my computer, everything is set to the Yeti, but for whatever reason, it just doesn't want to. I can't even when I switch in between different microphones and Discord, it just doesn't like it. So I guess I'll have to try a different browser or something next time. I'm not sure, but this will work
You
for now.
sound good.
Apologies.
Yeah, I was gonna say you sound good right now, man. So that's no skin off anyone's
Good.
back.
Cool.
I see you decided to join the Hat Club today.
Yeah, I wore a winter hat on the way here because it is freezing cold outside, and so my hair got all mangled up, and so I was like, you know what, I'm just gonna go with the hat.
So B, our COO, isn't here right now. She's using the Storm Chaser coaching account, and I think I'd put on your list at one point, B, your to do list to get all of our coaches some merch. If I haven't done that, tell me, and I'll put it on there. But we have to make sure all you guys get at least a hat and a T-shirt, so that way you can rep whenever you're on the
Yeah,
shows or out and about chasing.
yeah, that'd be cool. Um, yeah, especially a hat. I'll be wearing hats all the time sometimes. So, um, yeah, if it's free, I'll wear it all the time. You know what I mean?
Right? Are you one of those people where you'll like sign up for the free credit card application when you're like walking through a fair or something just so you can get the hat that comes with it?
No, well, I guess it would depend on the hat, but I usually try to stay away from that.
Cool, cool. And I see B is typing. She's probably about to tell me that I think that mic is also from us. Sorry, Kyle. Yeah, I do believe we sent you that mic. So.
Yeah, this is Gabe's magic microphone over here. It works great on everything other than what it was intended to be used for. So, I don't know. To be honest, it could be partially my laptop. So, this is a pretty old rig I have over here. So, hopefully, updating that here in the next couple months. But yeah, it's a great microphone. For whatever reason, Discord just hates it. So, and again, I'm using it on Chrome, Discord on Chrome. So maybe having an actual desktop application for Discord would probably fix things. Usually, that's the fix for things. But
Oh yeah, yeah.
yeah,
I definitely would recommend downloading the actual
yeah,
Discord app. It has a lot more functionality built into it, if nothing else.
yeah. We'll play with that here and see how that goes.
Radar Shark, you asked if you can shout out SEC in your next WX video. Yes, absolutely you can. Thank you very much for that, by the way. Free advertising is something that I'm never going to turn down. Unless you're doing a video on like your top 10 slurs, then I would kindly ask that you refrain from talking about Storm Chaser
Yeah,
coaching. But as long as it's within the realm of wholesome family oriented content, then knock yourself out. Top 10 slurs. At number 10, we have. All right. Okay, Kyle. So I was giving people a little bit of a chance to filter in here. This is the first time we've done office hours, A, on a weekend, and B, this early in the day. So I'm interested in
yeah,
seeing what the audience turnout is. It's a little bit of an experience. We figured it
yeah.
would give people, if we did these occasionally on the weekends earlier in the day, it would give people an opportunity who maybe work second shift and could never make it out to the ones on the
Definitely.
weekdays. So we'll definitely do this for at least a few months and see how the turnout is. I know it's already a little bit lower than what it usually is on the weeknights, but that just means
Yeah,
all of you in chat, and I see some of the Storm Chaser coaching crew, Storm Chaser Nick's out there, the meme wizard himself from Twitter. I see Stephen Cross, our junior coach, he's in there as well. So I'm going to need everybody to contribute, throw some questions out there, and I actually don't see Anna. Was Anna supposed to be the one that was doing the questions for today? I don't know, but thankfully we have a low enough head count here that I think I can manage just pulling the questions out of chat myself. So we will go ahead and roll the dice. We'll see how this goes. And the first question's coming in from Sanest Northeast Chaser. All right. So just a quick thing. What's Kyle's expertise? Want to make sure I'm not asking something Kyle can't answer. So let me say first of
that's
all
fair.
that Kyle can answer just about anything. There's a reason he is on the Storm Chaser coaching roster because I have been nothing but impressed with this guy since I first interviewed him for Chaser Chat 3 or 4 years ago and got to know him a little bit. So You do, though, that being said, have some areas of expertise specifically. So maybe if you wanted to share with people exactly some of the stuff you've worked on in the past and what you're working on right now, both academically and then as part of your side project.
Yeah, so I'll just kind of give a general background for anyone that doesn't really know a lot about me. So I'm currently a graduate student at the University of North Dakota, and I'm studying dynamics of severe convective storms. Particularly, my thesis research right now is actually investigating the role of rear flank storm interactions on storm behavior and tornado genesis. So essentially, what we're doing right now is trying to make companion research for the numerous observational studies out there that show that there is some kind of statistical significance to cases that have rear flank storm interactions and how that ends up triggering or instigating tornado genesis later on. So we're able to actually simulate that in numerical studies. This is kind of the first of its kind in the way that we're doing this. We're using CM1 to actually show that when a storm that previously couldn't produce a tornado is then interacted with in the rear flank, it does produce tornadoes that are stronger and they last for longer. So that's my research right now. So my general expertise is definitely severe convective storm environments, dynamics, and then storm interactions. Um, I would also, go into other things, I guess, beyond just the research side with Aurora and photography. My chase goal is photography, so I don't really shoot a lot of video or anything like that. I don't stream, but I'm out there positioning with the goal in mind of shooting photos and just trying to get good compositions, things like that. So I guess that would also work into my expertise. I also enjoy synoptic meteorology as well, and I think maybe you've seen some of the discussion on Twitter in the last few weeks to a month or so. There's been a lot of discussion on synoptics and how important they are when we're forecasting, and a lot of times they get kind of overlooked. And so that's kind of been a passion of mine recently. Gosh, Gabe, what else? Oh yeah, and then there's the Storm Chase Archive. So that's a project I've been working on with Cameron Nixon, Jim Tang, Coach Hunter. Let's see, there's a lot of other folks on that, but we've been trying to just create a library of the history of storm chasing and all the whether it's the media or the actual data from that event or just the log of that information. All right, we want to have an archive, a library of us, right? Our history, our story, and so that's what we've been working on over there. And then there's all kinds of numerous other things. I think I'm forgetting some things. Oh, programming. So the SounderPy Python package. I'm the developer of that. There's probably a few other things in there, Gabe. I don't know if you remember anything. There's kind of a lot going on right now.
I appreciate you sharing all of that, and that's why I was really excited to just kind of throw it your way and have you. I wanted you folks to know like the breadth and the scope of everything this man works on. You're what? Not even 25 yet, correct?
I am 25, and
Okay, you just
in
turned
just
25.
a couple
Okay.
weeks I turn 26. So
Oh, okay. So you're still
yeah,
though for being as young as you
yeah,
are, being able to have so many projects to your name and everything. Definitely, I would consider you to be right in that class of young minds in meteorology with Cameron Nixon and Hunter
I
folks
appreciate
and
that.
folks like that. So just been a pleasure getting to learn from you over the last couple of years.
I appreciate that.
All right. So Aurora, I have some questions about Aurora. So
Okay.
space weather is obviously something that a lot of people in the storm chasing community don't know as much about, at least not as much as they do about severe convective weather. I think a lot of people get into storm chasing severe thunderstorms, and then they find out about Aurora as a result of that. At least that's been the experience of people that I've known. It's something cool to do when there's not a lot going on the severe convective side of things. So if
Yeah,
people were wanting to start getting into space weather, and eventually at Storm Chaser Coaching on our YouTube channel, we will have some content for space weather, but we don't have that yet, and that's definitely probably a year or two off at this point. Where would people go if they wanted to start learning about that stuff? Like they actually want to be able to create their own forecast. They want to know which kind of locations they should target, what kind of camera settings, anything and everything. Where would they go for something like that?
yeah. So I'm going to type something in real quick to make sure I have this website right. So Yeah, so online, the best way to start learning about everything that you'll need to know from, really kind of beginner stages to in-depth stages. Some of this is free, some of it is there's you can pay. There's like first thing that pops up here is a free ebook. So this is the auroraguy.com. This is Vincent. Last name is escaping me at the moment. He's on Twitter. He's all over the place. He's the guy. Uh, he has the best explanations of some of the harder topics, why they're important to you when you're out chasing. He does tours and stuff in Alaska, so there's that sort of thing. But he also has this resources tab that has Aurora chasing FAQ. He's got a list of webcams you can look at and a bunch of different ebooks that explain different things. He also has a blog where he might just dive into a topic. So I'm looking at some of these on here. Yeah, top camera gear, different types of Aurora, what a substorm is and how to forecast them, how to use different things. So this is the place. This is absolutely the place to do this if you want to get into learning some of this stuff. The nice thing about Aurora is that it's a lot. Let me put it this way: in planning, it's a lot easier because you don't have to worry about driving hundreds and hundreds of miles and then chasing following something constantly and positioning and all that. You kind of just need to make sure you're in dark skies where you have a view of the north sky. But then, so that's kind of the preparation or the planning. And then the other half of that is actually making sure that you can, you know, figure out when the best time is going to be and all that sort of deal. So, that's where things get a little bit more complicated, right? The forecast process, I think, for severe storms and Aurora are very different in how complicated they are, but also in how much we understand the topics. We understand severe convective storms much better than we understand Aurora, and we can also, imagine you are trying to chase a storm. You can look at Meteor observations, you can look at satellite, you can look at radar, all these different things to figure out where a storm is. When we're waiting to see a CME come from the sun towards Earth, you have two satellites in between us and the sun. Sometimes only one satellite that can actually tell us um, where this thing is and when it's going to hit and if it's going to be favorable for Earth. So there's a lot of things that go into this, but the auroraguy.com is definitely the place to get started.
Without tipping my hand too much, that is definitely on my Christmas wish list to get him on board with Storm Chaser coaching at some point. I've mentioned it before on the show, but when we do start dabbling into space weather, I can't think of a better person to, potentially work with us and create some material for Storm
Mm-hmm.
Chaser coaching. So hopefully that he doesn't hear that or hear of that and get completely turned off. I will say this: he has rolled his eyes and basically admonished me on Twitter before, because every time there's a massive auroral event, I don't know if you've seen these posts
Yes,
that I make.
I've
I'll
seen
take
them.
like yeah, I'll take like a stock image from like Tromso, Norway, and I'll
Yeah,
just post it and be like, the aurora is insane
Columbus,
in
Ohio.
Ohio. Yeah, Columbus,
Yeah,
Ohio right now. And it's like a mix of 75% people telling me what an idiot I am and
yeah,
about 25% of people believing it. Wow, I didn't know it got like that there in Ohio. So
yeah. Those are funny because like when they're contained in the weather community, everybody knows it's a joke, right? So it's kind of
right.
funny. And then when you like we've been saying in the a lot of people seem to be breaching containment from the
Yes,
weather
yes.
community. When that happens, then it's madness, and people are like, "This idiot doesn't know what Ohio is," or it's hilarious.
My two most interacted with tweets of all time. One of them was a tongue-in-cheek tweet where I called out Ryan Hall and said he was the worst thing to ever happen to the storm chasing community, just to see what kind of engagement I could get, and his
Yeah,
fans went absolutely rabid on me. And the
yeah,
other
that's a
one was
choice.
when I posted that Aurora photo saying it was Columbus, Ohio, when it was clearly
Yeah,
somewhere in the Arctic Circle. So if that's a sad state of social media. If you want to get eyeballs on your content, unfortunately, that's what you have to do.
yeah. Sometimes, yep, that's all it takes.
Okay, so we got some good questions building up here now. Radar Shark is an Academy member. They said, since you need to start local, what if that local is Dixie Alley? Obviously, a little bit of a
Is this in
conundrum there.
reference to severe storms or Aurora? That's
Oh
the
yeah,
question
yeah.
I
So for severe storms, if a person is just getting started out, and obviously the advice is take it slow, you might want to chase somewhere where there's good visibility. You want to stay
had.
local. I know stay local is a big piece of advice a lot of our coaches talk about. And so what if that local is in the heart of Dixie Alley? What are some tips that you would give somebody for
Man,
those first couple of chases there?
that's an amazing question because I never plan on going to Dixie. It's just no, especially when you chase for photography, like Dixie's just not the place, right? If you want to get close and shoot video, or if you are, planning on, being there for damage or whatever, that is kind of what you have to be into to chase in Dixie. I'm never gonna get a nice good photo of what I have in mind for a good photo from Dixie. So I'm never gonna go there. So my opinion had always been I don't care about Dixie, but that's a great point. That's actually a really good question. Um, and because I'm not from Dixie and I don't chase Dixie and I have different goals when I go out to chase, I wouldn't say not to chase Dixie. Um, what I will say is don't chase Dixie alone for the first few times. What you need to do, and I think this goes for everybody, whether or not you're in Kansas or whether you're in Alabama, you need to find someone, especially if you've never chased before, find someone that will take you under their wing, mentor you, show you the ropes, and give you experience, especially in a place like Dixie. And again, I say this as someone who's never chased there, but um, on the plains, you have great visibility. Typically, the roads are okay depending on where you are. Uh, and the storm motions are usually slower. The storms usually just have better visibility with them as well. So, what you see in Dixie is you have I'll call it this amount of time to make a decision that is significantly less than it would be on the plains because of the road network, because of the visibility, because of the storm speed, all these other things, all these other factors, right? And so when it comes to making decisions, if you're in Dixie and you haven't been you haven't come up against a certain situation before, you're not going to know how to handle it. And when you do that alone, the first few times, that's a good way to get yourself in trouble. So, what I would recommend, again, for everybody, is find someone that will chase with you, someone with experience, someone that's willing to show you, okay, we got ourselves in this situation. I have experience with this. This is the right call to make. And then you soak up everything that they're giving you. That's how I learned to chase. I learned to chase from someone who was a very smart, safe chaser that focused more on what is this road like? Where's it going to take us? What are the escape options? If this storm starts behaving this way, what decisions are we going to make to keep ourselves safe, right? If I miss the shot of the year over something, that could have potentially been life threatening, I'm going to make the decision to miss the shot of the year every time because I know there's going to be another shot of the year next year. You know what I mean? So, when you look at it from a safety perspective and making the right decisions, what I would suggest is if you stay local, if you want to start local, that kind of thing, find someone that can help you do that because the storm chasing is just a game of decision making, right? And a lot of decisions are made based on prior experience. And if you don't have that prior experience, that's when, things can start getting a little nasty. And if you, especially in a place like Dixie, have much less time to make that decision, that's when it's easy to make an error. So that's my opinion there. I see Ethan is typing right now. Ethan might have some more to add to this. Again, it's kind of an opinion thing on what you want out of chasing and all that. So I guess I hope that answers the question.
Yeah, I see Ethan just typed all fun and games until you coronal mass eject. And at the risk
Yeah.
of being a little too NSFW here in office hours, I have been known to occasionally tweet out this amazing Aurora is giving me a coronal mass erection or something along those lines. So
Oh yeah.
gotta love the play on words there, Kyle. Ethan. I'm right with you, buddy. I'm right with you. Okay, so a few housekeeping things before we proceed forward. We have Hannah, who is part of our staff at Storm Chaser Coaching. She is the uh, what did we what did we decide on? Audience coordinator. Yeah, that's the term that we're using. So she is the audience coordinator for today. Hannah, very happy to have you here. If you want to unmute your mic for a second and say hello to everyone. I don't think I didn't tell her I was going to ask her to do this. So.
Hi,
Hey,
sorry,
Hannah.
hi.
How you doing today?
I'm good. How are you guys?
Doing great, doing great. So, Hannah,
Good.
if you ever want to interject with something, feel free to chime in, kind of like how on podcasts and stuff, occasionally the editor or the producer will pop in and make a comment or let us know if we're missing something. Feel free to do that, and we really appreciate having you here.
Absolutely. Thank you. I'm excited to be here.
Very cool. I also see we have our boy Stephen Cross, who is our junior coach here at Storm Chaser Coaching, our homegrown farm product. Stephen, great to have you here. And I will say, Stephen has asked before if we could actually get a soundings channel in Discord. He said he's seen it
Yeah, we talked
before where
about it.
you can. Okay. So
Yep.
I think that would be really cool if people could just type in a date and have a sounding pop up. So if you and him are ever able to work on that, obviously no rush, but that'd be a really cool addition down the road.
Definitely. Yeah.
Ethan, of course, very cool to have you back here. Your group coaching session was incredible earlier this week. Kyle, you're not going to believe this, but the definitely most impactful moment, the moment where the chat was most interactive and everybody was, let's say, most engaged, was when Ethan decided to share a story about what happens when you, how to put this artfully, neglect your nutrition and find yourself out on the road without a lot of options present.
Yeah.
So
Yeah.
we'll leave it at
Yeah.
that. But a lot of people connected with that. I guess it's something that
Ethan, I feel
happens
for
a
you,
lot, but
buddy.
that people don't
Yeah.
talk about a lot.
Yeah.
And then lastly, I'll give a shout out to Storm Chaser Nick, of course, the Twitter wizard himself, the meme god. Nick, I've seen your DMs that you sent me over the last couple of days. I've just been so busy. I promise I'm not ignoring you. I will get back to you ASAP. So I think that about takes care of everything I wanted to mention real quick. So we will move forward to, we got a lot of questions now. Stephen said, Stephen Cross, what's your opinion on the quality of EMLs? How do the EMLs at a deep digging trough over Mexico differ from, say, a trough advecting from the Rockies? And how might that affect tornado genesis / supercell characteristics? So I guess the way to compact that statement is basically, what are the differences between types of EMLs? You know, we talk about EML as
Yeah.
this monolithic structure, but it seems like there can be a lot of variation in the characteristics of each one.
Yeah. Yeah. So first, I'll give a quick background for anyone that's not super familiar with this. So the EML is the elevated mixed layer. A mixed layer in the atmosphere is a layer that is not always dry adiabatic, but usually has a steep temperature inversion. And then above that, the temperatures decrease rapidly with height. And on the other side, on the dew point side, usually you have a similar but sometimes opposite signal on the dew point side. So essentially that means that it's well mixed. So in this small layer, you might have really warm temperature and really dry dew point, and then they might come back together as you go further up the skew T. So how those form, and this is kind of the second part of this question here, as you know, whether it's the Rockies or down in Mexico or whatever. As you go from east, you know, you might have elevation here, and then as you go west, elevation increases as you get towards the mountain. When a system comes over the mountains, it's going to grab the air that's over that higher elevation and move it this way. But when you're in the east, your elevation is still down here. So you end up with this layer that's elevated over the ground in the east or at the plains. Over here, especially in the southern part of the US and over Mexico, that layer that's coming from over the west is usually pretty dry because, you know, desert areas down there, right? And on top of that higher elevation, there's not as much moisture. So when that layer is conserved and then it's vected eastward over the plains. It's elevated and it's well mixed because it's got warm temperatures and it also has the dry conditions. So that's what the EML is. There's a lot of work on trying to figure out what exactly drives quote unquote better EMLs. And I'll clarify here, when I say better, I mean for us as chasers, right? So in my opinion, we do want an EML. I like a cap, and just not too much, right? So this question depends a lot on the time of year, depends a lot on the drought situation that we have, right? If you have a lot of drought over over the Southwest and over Mexico, especially if it's like a long-term drought that's kind of been building up over time, those EMLs are usually going to be larger, which means they're going to be drier and they're going to have a larger temperature inversion in most cases. And what you're doing in the bottom part of the atmosphere is you are, when you start to warm up during the day and you start having convection, you are mixing the more moist air near the ground into that inversion at the layer where the inversion is, right? So the drier that inversion is, the more of your air in the ground level that you're going to be drying because of the drier inversion. This is kind of hard to do just with my hands here instead of having a SQT, but if you have drought over the plains, that can also start to make the EML more prominent because it's harder to mix the drier air out of the EML. So there's a lot going into that. But I would say that when there is just a little bit of drought over the Southwest US, kind of going up into the Middle Rockies, that is my kind of ideal EML, I guess, for the plains, right? If you want an EML further east, you're going to have drier or more dry conditions. That way that EML makes it all the way to the east. So it's a very objective thing too, right? Like I like slow moving storms that have good visibility, that are a little bit higher based maybe, and they're photogenic and they have photogenic tornadoes. Typically the EML structure for that is going to be different than, just getting a significant tornado outbreak in Oklahoma, right? So EMLs, there's kind of this scale depending on what you want. But, again, time of year matters too, but if you have enough warmth at the ground and enough moisture at the ground to still allow parcels to rise through that elevated mixed layer. That's kind of the key. I don't think we know enough yet about the origin of a particular EML and whether or not that's better or worse for a given scenario. Right? There's so many factors that go into it. An EML and a given EML strength and a given, surface environment might work when you have some amount of forcing aloft. Then that same combination near the ground or the lower levels might not work if you have less forcing aloft, right? So there's all kinds of things that play into that. And I just don't think there's enough research that shows the origin of the EML and which is better, which is worse. But the important thing about the EML from a chasing perspective, why I like them is because they help to limit the amount of convection. So maybe there's only one or two storms that initiate rather than several storms. And I also think it's important for the storm look. So if you have drier air in the mid levels, and if you have a little bit of inversion, so maybe there's maybe a little bit of a stable layer there. That's how you get some of that smoother, kind of pancakey, high visibility structure. If you have, let's just talk about convection, right? Convection is just rising air parcels, and you have a rising side and a sinking side, and that happens any day when the ground is warmer than the air loft. So in a severe weather sense, you might have this convection, and that is freely rising air because the air at the top is cooler than the air at the bottom. However, if you have an inversion where suddenly the air up here is warmer than it is down here, that convection is going to go up to the EML and stop and come back down. However, if you have a storm above that elevated mixed layer, right, and it's got a really strong mesocyclone, you can still pull those parcels up through the EML. And when you force some air up, not convection, when it is forced upwards, that's when you get that smooth laminar look. So that's why I like having an EML. That's why I think they're important. Again, like I said, I chase for photography, not up close video or anything like that. So depends on what you want out of the chase, that's for sure. But as far as where, I don't think we know enough about the origins or their association with given outbreaks or whatnot. Hopefully that answers the question.
Love that explanation. super helpful for people who might not have been aware of exactly what an EML is. And the last thing I'll mention is I know that for me, at least, when I was first starting out, hearing words like capping inversion,
Mhm.
sin, convective inhibition, EML, how interchangeable can you use all those terms? Because you'll hear them used in different contexts from different people to describe different things. Do they all sort of roughly equate to the same thing?
Yeah. So um, I'll start with inversion. Inversion is just any point where the temperature is warmer than above some point than it is below. So when you want rising air, you want the air to always be warmer at the bottom than it is at the top. And any time when the top actually ends up being warmer, that's an inversion. So that's not necessarily an EML. Well, right, you get inversions at night. So imagine your skew-T line goes down like this during the day, and maybe this is the surface, right? And then at night the surface cools. So you'll notice that over here, I guess to my perspective, this would be flipped for you guys, but this is now cooler than this is up here. So you end up with this inversion. So you get an inversion at night, but that's not necessarily an EML. You get inversions with frontal passage from radiative cooling, from subsidence. So in high pressures, like here in North Dakota, we have a high pressure system overhead today, so we'll have a subsidence inversion somewhere. But when you talk about the EML, that is particularly an inversion that has that mixed layer characteristic where it is dry and it is warm. CAP is a little bit muddier because people will use CAP for both a just any general type of inversion or the EML. I think it is best suited for the EML because that's what we see typically. I would not call a regular inversion a cap. For example, there was some discussion on the Enderlin profile. I think just a couple weeks ago, I believe, and there was
Enderlin
that
Minton, shout out to Ethan.
Yeah, yeah. The that Enderlin environment, right? The temperature had cooled at night because of that radiative cooling of the surface. There was also an EML in there, but you also had the radiative cooling, so it was kind of a cap in the sense of an EML. Cap and EML are mostly interchangeable, but inversion can mean many different things.
Now, drilling down even a little more granular, you talked about
Mhm.
subsidence
Yep.
inversions. Did I use that correctly? Yes, subsidence.
Yep.
Okay.
Yep.
Now, one question I've always had, I'm going to hijack this for a second, is when you're watching a shortwave, so let's say you're looking at a day
Mhm.
where there's a lot of like real mesoscale details that you need to pay
Yes.
attention to figure out where you're going to get the lift from your storms, these very subtle shortwaves going through. Is it important to time and well, I guess not only time, but also match up your location with making sure you don't end up in the entry region of one of these shortwave troughs, because that would create an environment where there's like a mini subsidence inversion in that area that might not be obvious at first glance, right?
Yeah, so there's a little bit to go in there, and I'll clarify. When you're on a day where you are looking at a shortwave, right? So you have these big long wave troughs, right? That might cover the whole half of the United States or something, and then you have these smaller embedded waves, short waves that kind of traverse through these larger troughs. And those sometimes can be, half of a state in width. And I actually think back to a event in August of this year in North Dakota. It was a um, uh, in August 7th, maybe. I don't remember the exact date, but it was an enhanced risk in Western North Dakota. A lot of folks were out there, and it was a bust because the timing of the shortwave was bad. So, without going too crazy, right? I mentioned at the beginning this synoptics are important, so I'll mention this quickly. When you have the shortwave moving through on the forward side of the shortwave, or the eastern side, just kind of think of it that way, you have lift, and on the other side of that, you have sinking motion, and that's because the curvature around the curvature around the shortwave, you get positive vorticity advection on the right side, and you get negative vorticity advection on the left. Positive vorticity advection gives you lift. So you want that shortwave to be timed right with when you have the best thermodynamic environment over your target area. And if the shortwave moves too fast, then what you're going to end up with is not enough lift over a given area to help support that growing convection. So, and just another kind of backstory thing here. There are multiple ingredients. You can't just have instability for storms on most cases. Think of SLIM, SLIM, shear, lift, instability, and moisture. So you have lift and instability. So you have convection happening in instability, but then you have that short wave for lift. That's why that's important. Now, in this North Dakota August event earlier this year, what happened was we had a nice thermodynamic environment that was building. You had Q going up, and this shortwave just moved too early and too quickly over the area. So by the time we didn't get into the when we got into the afternoon and the evening, when things should have been firing off, we ended up on the sinking side of that shortwave. The easiest way to tell that from observations, and this was clear as day when we were out there that day, is on the right side of that shortwave where you have lift. Usually, if there's enough moisture, you'll actually see cirrus clouds high up there. And that cirrus is associated with that gradual lift and that moisture. If you see that kind of just swinging through too fast or too early, that's a sign that the shortwave is moving too fast and too early. So, yeah. And again, for some more background here, the subsidence is sinking air. And so sinking is going to suppress any vertical motions that you have. Like convection is sometimes when you have that cap, right? You need that little bit of lift to break that cap so the storms can get going. But yeah, it's a really finicky thing because models can do pretty poorly with handling the timing of short waves. When you look at super fine mesoscale models like the HER, I guess here we go, Gabe going into the modeling stuff again. But when you look at the HER, it's got a really fine resolution of 3 kilometers, and it can actually resolve too much detail in the short waves and actually cause them, because they're a larger feature, and so they end up moving too fast or being the wrong shape or whatever. So there's a lot of stuff that goes into that. So sometimes they're hard to model, and really it's observations that help time things correctly. It's kind of the best way to put that. I think that answered the question. I'm doing a lot of randoming here.
I apologize, chat, for monopolizing the questions there for a few minutes. So I will get to the rest of yours, I promise. Starting with Storm Chaser Nick here. He asked, I see it will be warm in North Dakota this weekend. Are you going out for the Geminids meteor shower?
Yeah, so last year I missed it because of clouds here on the best night, and so this year I told myself I'm gonna do it because I did it the year before, and it was great. As you know, Nick, it will be a nice warm, probably -20 tonight, and probably like -10 tomorrow night. Wind chill -30, -40, which isn't that bad. No, actually, so the joke here, we have high pressure over us right now, and the high pressure is when you have that high pressure cold here, it's actually quite a bit warmer because we have the sun and not a lot of wind. So even though it might be -20, air temp or whatever, it doesn't feel as bad as -20 wind chill. But probably not. We will have clear skies and everything, but no, even though it will be warm, yeah, no, it's a little cold out. My car struggled to start this morning, so the last thing I'd like to do is it be -20 and then drive out in the middle of nowhere and be stuck because there's no place I can plug in the heater out there. Yeah.
Okay, so I have Radar Shark coming in with a good couple of questions actually here. I think these are both from Radar Shark, but I'm going to package them together even if they're not. First of all, do you think there would be tornadoes on Mars if we terraformed the planet? And then packaged together with that, another thing on Mars. I was talking in a space Discord about Mars dust devils, and they were suggesting that the dust devils there are not convective based. They're just small circulations based on surface convergence. But I think that can't possibly be true because of the sheer size of some of these things. So, Kyle, have you ever thought about that before? Do you have any opinion on that?
So yeah, I'll answer the second question first. This is actually really interesting. I don't know a lot about the atmosphere of Mars, but I know that there's not much of one. And the fact that we have the atmosphere composition that we do here, that allows us to have convection because we can warm the surface so easily. So it is much more difficult to warm the surface in Mars, further away from the sun. But you also aren't holding in heat with our atmosphere. So every time the sun rises on Mars, you're basically starting over. Whereas here, we're not starting from 0 Kelvin or whatever. Here we have warmth that's held in overnight on Earth. So it's possible there's a convective aspect there. I don't know enough about it to really say. However, if you have, and there's friction, so this isn't going to entirely be true, but if you have pure like cyclostrophic balance rotation, which is just spin, essentially for the sake of this conversation, that can dynamically end up pretty tall and pretty large, depending on the flow field and things that are happening. However, to get flow in the first place, you have to have some kind of thermodynamic difference, right? That's why we have the wind here on Earth, because there is density gradients, because temperature is warmer at the equator than it is at the poles. So there has to be some kind of thermodynamics in place there, maybe enough convection for a little bit of upward motion kind of near the ground. But it's not necessarily the same process that we think of convection here. If we terraform Mars, would there be tornadoes? I guess I don't know everything that goes into terraform, but I would say no until there is precipitation. My hot take here is that tornadoes don't form without downdrafts, and that I guess can be discussed a little bit at a later time if people have questions. But it has to be raining. So I guess I don't know if terraform includes making an atmosphere out of Mars the way that we have it here, but I think you'd have to do that. You'd have to have the same atmosphere we do here, or close to it.
I have to shout out our boy Steven here. He posted a picture of Jupiter's great red spot and said NWS Jupiter has been asleep at the wheel for hundreds of years. So
Mike Smith is livid somewhere right now.
That is too funny, Steven. Very well done. Very well done. Okay, so Ethan has asked, Kyle, what's your favorite underrated chasing area outside of the Dakotas? And I'm glad you qualified that, because this guy, let me tell you, man, Dakota this, Dakota that. That's all I ever hear about him is the Dakotas.
Yeah, dude. I mean, I love it up here so much. Chasing Convergence is less. It's getting more and more every year, but I like it here. Roads are usually pretty good. Cell service is actually surprisingly pretty good up here. But Ethan, I've been thinking about this question since I seen it popped up in the chat, and I haven't really picked a place because you said underrated. I think the last couple of years, Eastern New Mexico is no longer technically underrated, but unbelievable. I love the high plains in general. I mean, that's my go-to. So anywhere Eastern New Mexico, Eastern North Dakota, or Eastern Colorado, Eastern Wyoming, Eastern Montana. I love chasing those places. The roads aren't as good. Radar coverage isn't as good. But I love my time in Montana. Of course, everybody loves Colorado, but definitely New Mexico. I mean, just again, coming from the perspective of chasing for photography, you cannot get a better landscape than some of those places up on the high plains. So yeah, that's the thing, Ethan. No road. That's my hesitation from picking that as the spot. But it seems to be my favorite places to chase don't have any roads. So yeah, I definitely
biased.
We're in the high plains, really.
I'm a little biased on this one, but I'm going to go ahead and throw Western Ohio out there. So when you get right along the Ohio-Indiana border, it's not terrible for like
I've chased
little stretch between like Indianapolis and then like just north of Dayton. You actually get some really nice chasing terrain.
Yeah, and that even goes into northwest Indiana as well. Parts of northern Indiana, but definitely northwest Indiana. I saw my first tornado there. I've chased many times in northwest Ohio. The most amazing thing about northwest Ohio is that, at least in some of those areas closer to the Michigan border that I've chased in, friggin' almost every road out there is paved, which is unbelievable, and it's a crazy grid too. So, there's some places further east that are pretty decent. especially Ohio, Indiana. I really wouldn't put Michigan on that list. The thumb of Michigan's great, but they just barely ever get storms there. But yeah, again, I have a north and west bias for my chasing, so I'm definitely gonna stick with the high plains though.
And I will caveat my Ohio endorsement by saying if you ever find yourself flirting with Interstate 71, do not go to the east. If you go to the east of Interstate 71, just go ahead and find yourself a Sheetz gas station and get something to eat because you're calling it a day at that point.
Done. It's done.
Yep. I see some people who are local because I live just to the east of Interstate 71. So the chasing terrain here is basically the foothills of the Appalachian Mountains. And I see some local chasers who will get into the actual like
Beating
mountainous
Berry.
terrain. Yeah, down by like Ohio University and stuff. And I'm just like, you people are freaking nuts. It's basically like Dixie without the payoff because you never get the storms that are strong enough to give you like a crazy wedge once in a lifetime chasing experience. So you just get all the slop with none of the reward. And that is chasing the Appalachian Mountain region. It's just not worth it at all.
Yeah. I see one comment on here. I'll add. Canada slept on. I've never been able to chase in Canada. I need to get my passport. The reason is I don't have a passport, even though I live an hour and a half from the Canadian border. But I need to get my passport this winter because yes, Canada is 100% the most underrated place to chase. The nice thing is like you don't necessarily need to be on the high plains to get those crazy like high plains like structures that we get here. They just happen everywhere in the prairies, and they are they're crazy, and the grids aren't that bad. There's a couple other things you got to get used to up there, but in general, I mean that's a great place to chase, and I hope to be able to do that this spring and summer.
All right. Next question from Storm Sync WX Connor. I wish I had some questions. And then they ask a question. So come on, Connor, get
Nice.
with it, man. Like, I wish I had some questions. Here's a question. Okay. Is that the quickest wish fulfillment of all time, by the way? Maybe that's what's going on there.
Yeah, just got to get the wheels spinning. That's all.
Connor wants to know, Kyle, what type of camera and tripod do you prefer for your storm photography?
Yeah, so I mean, the camera's kind of a camera is kind of a whatever you want out of your gear, whether you're into photos or videos or whatnot. But the biggest thing I can say about the tripod, and I don't have them in the room here with me at the moment, but is a heavy tripod. So a lot of people have lost many a camera and camera gear from light tripods get blown over. We find ourselves in inflow and outflow and all kinds of stuff all the time, and even though it's kind of legs going down, it's still top heavy and it's really easy to get knocked over. So a good heavy tripod is the absolute best thing. I have a Manfrotto tripod. I forget what the particular model number is, but it's it's kind of the middle ground between super heavy and kind of middle. But yeah, it's a nice tripod. The camera that I have is the EOS RP. I believe they actually stopped making that, but it's the EOS R series. It's like the first one in that. So it's a full frame mirrorless camera. It more so designed for photo than video because that's what I'm into. But it's kind of just whatever you're comfortable with. Let me see. When it comes to other camera gear, I think the best thing that you can do for yourself is have a lens that has a decent zoom for when you can't get close. If you're on certain roads in Texas or these roads in New Mexico or whatever, and you're pretty far away, a good zoom lens, or if you have the ability to get a little bit closer, a wide angle lens. I mean, some of the better shots are going to be the wide lenses. Something like 12, 14 millimeters. I have a 16 millimeter lens, so it's not like terribly wide, but it gets the job done for most situations. My biggest recommendation, though, would be no matter what camera you have or what gear you use or whatever, learn how to use every aspect of that camera. So I really am a preacher of manual mode. You don't need to know manual mode to storm chase, but I think you can get a lot more out of your photos if you are in. I don't want to step too much into Mike's lane here, but using manual mode, learning how to adjust for certain light or certain focal lengths, all that type of thing, which is different for every situation. I think that's something you can really really increase your style, and you can increase your productivity and in the quality of your content if you really know how to use your camera beyond auto, like the auto settings.
I don't think Mike would mind. In fact, I think what you just shared is exactly what he talks about. So I think he
Mhm.
would probably give a full-throated endorsement if he was here right now.
Well, I hope so.
All right. So sanest Northeast Chaser requested
Mhm.
to speak. It looks like their hand is still up. So let's go ahead and pull you up on stage. And just a reminder to everyone, you are allowed to raise your hand and ask your question IRL. You don't just have to type it in. So sanest Northeast Chaser, what's going on?
All right, I'm not muted anymore. Okay, sorry. Um, so the other day, instead of doing more productive things, I was watching tornado videos, as one will
Mhm.
do. And I remember watching specifically, there's one with Smithville, one with Joplin, and another was Bridge Creek 99.
Mhm.
And I was watching specifically the tornado genesis was like with Bridge Creek, it was kind of slow, a little bit more spread out, slower. You could really kind of watch it organize and kind of get into this huge hulking thing. But then
Mhm.
with both Joplin and Smithville, it was very much kind of like a very fast, very violent thing. And
Yeah.
I was thinking about what exactly could cause that kind of deal. And I came up with this hypothesis. I have no way to prove it.
Mhm.
Um, but I was thinking of like those kinds of slower, um, more organized kind of developments happen if you're like you might have a really good environment like shear wise, but if either you have poor thermodynamics or you're having or struggling with dry air entrainment, and if you're
Mhm.
like waiting on several updraft mergers to really and it will slowly kind of get more better with stretching and organization
Yeah.
and that's kind of how you get like a situation with Bridge Creek versus something like I was thinking with either like Joplin or Smithville or just anything if you have like a really thermodynamically good environment and you're
Mhm.
just waiting on either like either some kind of boundary interaction or a nudger or something and then it'll just
Yeah.
immediately just like go nuts. And that's kind of I feel like what would it would take to have like those kinds of things where it's like ready to go, and then just as soon as everything lines up, it just goes. So, like that was just a thought,
Yeah.
but I have no way to confirm that.
Yeah, well, first thing I'll say is just thinking about it. That's the important part, right? Pondering why things behave the way that they do. That's the way everybody gets started. And I want you to know it'll never end, so don't let it end, right? But yeah, there's the fact of the matter is we don't know really enough about exactly what is triggering the beginning of tornado genesis to know for sure. What I will say is that the hypothesis of certain environmental variables being at play is probably the case that leads to this. So it's probably a function of storm behavior and orientation, because we know that tornado genesis is happening by the combination, or I'll call it the collection of little subtornadic vortices underneath of the meso. So you might have all kinds of vortices just kind of spinning around all over the place. And what's going to happen is those vortices, which are kind of tiny, right? Just think of like little leaf whirls and things, just a little bit stronger than that, but picture that in your mind. And then as they start to like collect and converge into a single vortex underneath that meso, that's when they start to, congeal and stretch vertically and then become attached to the meso and become tornadic. However, that collection process, and this is something we've actually found in my work here at the University of North Dakota, the collection process of that vorticity really is tied to the orientation of the RFD, orientation of the meso, how strong the meso is, and a lot of that goes into storm behavior. So one thing that's important here is if you have, let's say you're looking at the forward flank, right? You might have vorticity coming down the forward flank towards the meso. If the RFD is not forward enough, that vorticity will slide right underneath the meso and be gone. So that mesocyclone is kind of sitting here and the vorticity is moving underneath of it, and it's not staying under it long enough to be kind of collected and stretched vertically into the meso. So there are two things that can be happening. One thing that we think right now is that the RFD is actually, if the RFD surges forward enough, it actually helps collect that vorticity and prevents it from sliding away from the meso. The other thing is if the inflow is actually too strong into the storm, a vortex underneath the meso will actually be advected away. Think about when you see a rope out tornado, right? And if it's connected like this and the tornado ends up kind of with this bended kind of rope structure, that's because it's being advected away from the mesocyclone during that occlusion process. But we think that might actually be happening with these little vortices before they even become tornadoes. They're carried away before they're under long enough to become tornadic. Now, the idea of the rear flank interaction, this specifically plays into my work. The rear flank interaction might actually be promoting RFD surges forward that help in that collection process. And if these nudgers, as Cameron calls them, are just rear flank interactions in general, as they are continuing to kind of push on that RFD, they are keeping that surge pushed forward. So any of that vorticity that comes down here gets stuck from the RFD and sits under the meso and is able to get stretched. So in the cases that you presented, it's possible that the inflow was too strong or something about the storm orientation was just not favorable enough to collect vorticity fast enough. Like in the Bridge Creek Moore case, like I said, it was a little bit slower. Maybe something about that storm just wasn't set up just right yet for that process to take place. Exactly what governs those processes as far as the environment's concerned, we still don't know yet. And that's still an active place of research right now. And we know kind of in general what gets a certain meso strength and all that. But as far as specific orientation of certain features around each other, we just that's something we don't know yet. But I would definitely imagine that it's something to do probably with the downdraft thermodynamics and that low-level wind shear that's somehow governing the storm behavior and orientation of certain small features like the low-level mesocyclone, the RFD, that type of thing. So there's definitely a lot that goes into that. But that's a great observation. That one thing we need to be able to, from an operational standpoint, is determine, okay, we know that this storm might be tornadic, but when, right? That's a question that we're still trying to really figure out. And that's a good example of that. You have these high-end tornadoes, but some of them take longer to develop. Some of them are much faster. So that's definitely a good question. It's a very complicated process for sure. I hope that wasn't too confusing, that answer. Trying to draw things with my hands over here.
No, I like it. And in the future, if you ever want to as well, I know that there's not a whole lot of prep time with questions that come in during office hours, specifically since it's all over the place in terms of the things that you can get asked. But if you have anything that you want to bring up on screen, and we can get your desktop working. Yeah,
I'm gonna try to, and again, I'm on my phone at the moment. I'm gonna try to drop something in the chat here. Let me find this. So this is actually only a few people have seen this. This is from my simulations that I'm doing for my thesis research. Let me give me a second here to find the right one. What you're going to see here is a simulation, and don't worry about too much of the details because some of it's going to be a lot. But essentially, what you're going to see in red is positive vorticity, or a vortex that's pointed upwards, that's cyclonic, or blue, which is anticyclonic, pointed downwards. And you'll see these little pockets of vorticity. On one side, on the left, is going to be a storm that is not being interacted with, and on the right is a storm that's being interacted with. And let me find the right one to show you here. I think I'll do this one. So let me throw this in the chat, and then I'll let you guys kind of look at it here. So this is from a simulation. Again, on the left side, this is the storm that is not interacted with. The one on the right is a storm that's being interacted with. You don't actually see the interaction here, but the dashed line, the thicker dashed line, that's the reflectivity. And then the fill there in the red and blue, that's the vorticity. When you see the thick black like dot on the right one, that's a tornado. You do not see that one on the left. Notice that the RFD is pointed more east on the right, and that vorticity is kind of collected under the meso, which is the kind of thin, solid contour. On the left side, though, notice all those little red pockets. They're on the forward flank / left flank convergence boundary. And that RFD is not forward enough to collect them. So look at how small the meso is. And those little vortices are actually just going right underneath of them. You can see that in the animation. And so you have this large area of those red blobs to the south of that meso that were not collected or utilized in the tornado genesis process. So what we think here is that the forwardness, for lack of a better term at the moment, of the RFD probably is playing a role in collecting vorticity underneath the meso from the forward flank or the left flank convergence boundary, or some kind of like environmental ambient vorticity. So yeah, and again, the one on the right is a storm that was interacted with. So the one on the left is the same exact storm without an interaction. So the interaction seems to be. Let me set up the timeline here. The interaction seems to be promoting different RFD behaviors that support continued elongated tornado genesis.
I see Ethan chimes in, stealing watermarking, sewing to AccuWeather. So
I knew that was coming. It's okay. They'll probably call it a tropical cyclone anyway. So
land hurricane.
Yeah.
That's incredible. That research that you guys are doing is incredible as well. I have a feeling that we'll have to at least do a group coaching session about this at some point in the future once you've got a little bit more established and you're ready to share a little bit more of that research. And I definitely would love to have you create some content for the YouTube channel in the future as well, talking about this stuff, because it's absolutely revolutionary in terms of how you handle, going out chasing and deciding which cells you should actually, because the conventional wisdom has always been, right, I want to go for the cell that has the most clear air in front of it, because that's the cell that is going to obviously have the most fuel to work with. And the research that's coming out now is completely turning that on its head.
Yeah, so there is still an importance in the inflow region to make sure you have clear air. But when I said before about needing a downdraft for tornado genesis, this is what I mean. And it seems like in some cases, the downdraft that's just present in a given supercell, that RFD, its behavior is, and again, I'm speaking very unofficially here. We don't know all of this stuff for a fact. So this is kind of a theoretical discussion here. In my opinion, it seems that some RFDs don't have the proper behavior to help in the tornado genesis process. We know that the RFD is necessary, but I just mean that some don't have the right orientation or behavior, evolution, whatever, and it needs help. And that help can come from the form of the interaction. But as far as the research goes, this is my master's work, my master's thesis stuff here at UND. I hope to defend later this spring and into summer. So probably within the next couple months, Gabe, I think I'll have enough of something, even if it's just part of a live coaching thing or whatever. But yeah, I think I'll have some stuff. I'm going to be prepping some presentations and stuff for the spring. So we definitely chat more about that here soon.
That is awesome. So looking forward to it. And I'm going to throw this out there from Steven real quick. He said, I know questions are closed, but I thought this was a thoughtful enough question that I wanted to throw it your way while we're still on this topic. He says, so when the RFD surges too far south, it can essentially miss the meso?
Yeah, so I'll clarify here. What I think the point is in your head, imagine a storm that's moving due east. Okay, let's all get our bearings here. Imagine the storm is moving due east. So the hook echo is like this, right? Inflow is coming in this way, and the storm is moving like this across the map in your head. And I'm going to just turn my hand, right? So this is an RFD. I'll do it this way. I'll try my best to use your perspective here. So this is an RFD that's pointed due east. This is an RFD that's pointed due south, just on our little map here. Right?
Sorry, Kyle. Just a heads up. I believe that they actually see it reversed correctly. So you see it the wrong way.
Okay.
They see
Perfect.
it the right way. So
okay. So just imagine it like this, right? This is an RFD pointed east. This is an RFD pointed south. So what's going to happen here is if you have a left flank convergence boundary or forward flank that's bringing vorticity down this way, notice how on a southward pointed meso, this can actually slide right past. But if the RFD is pointed this way, then this vorticity comes down and is now stuck here. I think that's kind of the point that with the collection idea is that the RFD is actually kind of containing the meso and the vorticity, so to speak. And if the orientation is not favorable, it just can't do that. So I think that's the idea, that this RFD coming down, or the vorticity source coming down and getting caught on a more eastward surged RFD is important in this particular frame of reference versus a southward one where this is kind of sliding right past. Hopefully that makes sense. These weird,
that's so cool to think about, because it makes sense,
I'm
right? It's the difference between crosswise and streamwise, essentially, right?
Yes, and the interesting thing, you can actually think about it that way, but it is like streamwise relative to the very low level meso, not necessarily the storm motion, which starts to get really, really trippy. But yeah,
It's
I
cool
think
though, because it's introducing like a lot of additional stuff for you to think about in the field. And this is one of the things I talk about with Trey a lot, is that you might think that, like, if you first get into storm chasing, you're like, oh, this is stupid. Like, all I have to do is read the SPC outlook in the morning and go sit in the middle of the bullseye. But it's like, no, it's like once you get to, like, especially the storm scale type stuff, like the things we're talking about now, there's so much that's going to, I believe, in the coming years go into forecasting which supercell you should be on, where you should go. Because timing is everything. How many times have you been on a supercell that, dang, it produced 15 minutes later? Once, so.
Yeah, and then a lot that goes into this too is, I'll just use the 10 bullets here. Forgive me, Ethan, I don't remember what all of the bullets are specifically, but a lot of that has to do with decision making, making sure that you are in the right place to get what you want, but also be safe, right? When you are in a situation where the storm is behaving in a way that you don't expect, it makes it harder to make the right choices. And if you understand certain behaviors like RFD motion and all this other stuff, it's going to help you visualize better how the storm is behaving and how it might evolve, which is going to improve your decision making. So I think it's it's a safety, situational awareness thing too that could play into this for folks in the field.
Radar Shark, Chaser Academy member, coming in hot with the question, why are storm chasers insane people? So
you know what? That's a great question. My favorite thing about coming to grad school is interacting with people that are just as insane as we are, but for their own things, like whether it's rocks or the bug people here or the airplane people here. Everybody is, people like us have, and I'm gonna do my best to. Yeah, I see how the chat is reacting to this. I'm just gonna keep it straightforward here. People like us, we just like certain things, and I think some people don't get that. They don't understand that, and to me, I think that's a pretty sad way to live their life. But everybody's got their own thing. They chase it differently, but we're all chasing after something. So. That's the way I'll answer that. We are insane, but I think it's okay, is where I'm going.
We wouldn't have it any other way.
Yeah.
All right, Kyle, last question, and I apologize for keeping you here a little bit over schedule.
We're good.
You've been given such great analysis and discussion with the stuff you're working on that I couldn't help it.
No problem. And again, Gabe, if there's other questions that like we haven't touched on or whatever, that's fine. I don't have anything to do here for a while. I don't know what everybody else's schedules are, but The only thing on my schedule tonight is another hockey game. So
Oh, nice. So you and Ethan must get along on that front as well.
yeah, I mean, we're not going to get into the NHL right now, but college hockey all day.
Okay, yeah.
Yeah.
Sounds like there's a little bit of tension there, but we'll
Maybe.
go ahead and let it stay unresolved.
Yeah.
We do have one last question from Falcon Storm Chasing.
Okay.
Shout out to Falcon Storm Chasing. Steven is always talking highly about you, so that's got to count for
I
something.
appreciate that.
Kyle, how do you handle or counter overconfidence when it comes to forecasting? And before you answer that, I'm going to go ahead and throw out an important lesson that I learned from watching your forecast models training module in the Chaser Academy a few months back, which is being able to at all times know that the models are always wrong and they're just best
Yeah.
approximations or estimates of what we think an environment might be. And that always sort of sobers me up when it comes to forecasting, because if I'm basing my forecast off of what the models are showing, I know that my forecast is already wrong before it even leaves the station. And that sort of takes you down a couple of pegs and forces you to come to grips with the fact that, it's not like anybody has the perfect picture of what's going to happen, and you're really going to have to try to synthesize a lot of different pieces together.
Yes. So if you seem to come across folks that are always on storms, or they know everything, it's experience. They learn the quirks of observations and models alike, and they learn to really interpret the atmosphere's behavior beyond a model forecast, or even just what a certain observation is, right? They have this kind of intuitive atmosphere in their head, and that a lot of that comes from experience. So that is the best way to fight overconfidence, is just to kind of build that up. And again, that takes time, takes experience. So it's not easy to do early on when you're first getting into forecasting. But like you said, the way you said it, Gabe, was perfect. You just have to understand that we don't know everything. We probably won't know everything for a long time. Models are wrong. They are tools in our toolbox. You might need a hammer. If you're going to build a house, you're going to need a hammer for something, but the hammer's not going to build the entire house, right? You might need, you're going to need all kinds of things, different tools, different materials, right? So, when you're looking at just or even just the models in general, you can consider the models as the hammer, right? You can't just use the hammer to build the house. So when you are sitting down and forecasting, you kind of just have to recognize that what you're looking at is either old, wrong in terms of the models. Observations could be wrong. Technically, there could be something wrong with this sensor, or they're old. When you look at a sounding, you're not actually looking at the atmosphere above one point, right? That sounding gets carried away in the wind. So that's not even a true location thing, right over a single location. Everything that you see is not the actual current state of the atmosphere. So I think the thing that can really slow your overconfidence is recognizing that you don't know, and trying to do your best to utilize the tools that you have to get a picture. And when you are forecasting, and this is specific when you're forecasting for chasing specifically, putting yourself in a position for all of the possible outcomes, not just the one you're wish casting for. So you're like, oh yeah, all these models have this one supercell over this one county, and the Texas Panhandle, whatever, this looks great, that's where I'm going to go, this is perfect, good, whatever. That is you wish casting for that, right? That's not the all possible outcomes. You want to put yourself in a position to be available for all those outcomes. Weight yourself to one or another or whatever, but recognizing that things are wrong, recognizing we don't understand the atmosphere, and doing your best to put yourself in a position for everything that could happen, I think is the best answer to that.
Awesome. Well, I think that about wraps it up for today. So, Kyle, really appreciate you dropping all the wisdom today and hanging out with us here for a little over an hour. Chat, thank you for being Ethan with the 10 bullets. Couldn't resist. Had to toss the 10 bullets out there. Love it, man. By the way, if you folks didn't have a chance to attend the group coaching session, either you're not a Chaser Academy member yet, which, by the way, we are offering 30-day free trials right now for this new Chaser Academy. We kind of pivoted into a more live interactive model, which is just now over the last week starting to play out. So lots of cool stuff coming. But you can join over on the channels list on the left-hand side. Just go to the Chaser Academy channel, click the link, set up your 30-day free trial, and you can even watch the episode with Ethan from earlier this week if you'd like. But he talked about the 10 bullets in there, and he did a great job of breaking them down and sharing what they all meant and why they were important for his chasing strategy. And I believe he also said that there is an ebook, a PDF that you can download. So Ethan, if you want to drop that in the chat real quick so that people can have access to it, that would be pretty cool. All right. And
Ethan,
I see
you should
you
make
just started nerd, just nerd. Okay. All right. So
Yeah.
we're at that point of the afternoon.
Ethan,
A lot of-
you should make this into a little binded kind of book kind of thing that's on the June 1st merch store somewhere. I don't know if that's a thing already, but I think like as long as it wasn't like $50, I would buy one of those, you know? Even if it's
Ethan,
even if I'm not going to read it every day, I'm still going to look at it and go, okay, I need to like reset my head, you know, and just consider the bullets, even if I don't know what they all specifically are. It's kind of just that mindset of seeing it and knowing, you know, like something small to keep in your car or whatever. But you should stop being busy and work on that.
oh gosh, Ethan's up on the stage here now. Here we go. All right.
Yeah, I'll get on it eventually. When I'm done making insane maps for videos that take me a day to make.
Ethan, okay, I meant to mention this to you the other day.
Jason.
Got it.
I meant to mention this to you the other day, Ethan. If you're interested at some point, we can absolutely set you up with a funnel on our CRM that we use to manage our websites and everything else. So that way people can enter their email address, get the ebook automatically emailed to them. And then you would also be able to start a mailing list. I don't know if you have a June 1st mailing list yet or not, but
I don't. I'm like such a bum when it comes to that stuff personally. I'm like the poorest business mind imaginable, but somehow I make it just work enough that I can pay rent and put a little bit in a 401k or a Roth IRA. That's kind of my
tax advantaged. There we go.
Yeah, exactly. I'm pulling up the what's it called? The link. It's like it's a Patreon link, but it's not like you don't have to pay for it or anything.
Gotcha.
It's like completely free.
Yeah, from starting of SCC this last year, I've had to just delve into so many different aspects of business management that I would have never learned about otherwise. So if you ever do want if you ever want to formalize that a little bit more with June 1st and the ebook and that sort of stuff, I can definitely hook you up.
All right, good to know. It's this Discord, right?
I figured I'm never going to be as talented of a meteorologist or a storm chaser as all of you folks, so I better figure out a different skill set that could at least be valuable to everybody. So this is the niche that I decided to drill down into. Where'd he go?
Is Kirk still in here? I saw Kirk was in here earlier.
Wait, Kirk was in here?
I think Kirk was in here.
Oh man, Kirk.
Did I see Kirk?
Legend.
Hold on. It was like way up here at the top.
Wow. Kirk left.
I might be stupid. I might be stupid. Hold on. Ethan, was Kirk in here?
Yeah, Kirk was in here for like 3 minutes.
Where did he go? God dang it, Kirk. Anyway, I was going to shout Kirk out real quick. Kirk
Northeast
is like, he low key is a invaluable resource to this community with the you're only given these 12Z maps things that he does on Twitter. If you want to learn how to forecast, you need to participate in those because, like I said, modeling is one tool, but models are wrong. If you are trying to forecast a severe weather event from just 4 maps from 12Z the day of, that is how you learn the meteorology. I wish he was still in here, but like the things that you see, because of course you look at 12Z maps, right? But then you go and look at the models after that, and you might kind of forget in your head what those maps look like, or what they told you or whatever. But just being able to like look at nothing else but 4 maps is really, really a big deal. So
let
it
me
gets you
let,
thinking. Oh, sorry.
I was just going to say, let me piggyback off of that thought, Kyle. We have
Yeah.
forecast challenges that Trey had been doing. The
Yeah,
problem
that's
we were
true.
running
Yeah.
into is finding a format where everybody would be aware of them and participate, because what ended up happening is we were posting them originally and either nobody was seeing them, or perhaps the format we were putting them in just wasn't conducive to people actually being a participant. So if anybody in chat has any suggestions, if they have any ideas about, we're sitting on, God, I don't want to speak for Trey, but at least like 10, 15 forecast challenges where he's actually got all the maps pulled, and then he's recorded a review video afterwards to actually go over everything and let people
Nice.
know what actually happened on that day and what they should have actually been looking for. So we've got all that content. We're just kind of like sitting on it right now, trying to figure out exactly how we want to use it in the future. And I'd love to share it with folks, because like you said, it's probably the best way to actually from first principles figure out how to make a forecast. And then you're not relying on STP or updraft helicity tracks or anything like that.
Don't get me started. Ethan, when was that UND game that you were talking about?
Against Quinnipiac?
Yeah, was that
was the
last year?
2016. No, that was the 2016 finals. UND
Wait, what year is
shut
it?
out Quinnipiac in the final.
Yeah.
For the national championship. But we got the national championship in 2023, so I'm less salty about it now.
Okay.
So.
Sorry. I wasn't here, so I'm not going to take credit for that. So.
Oh, no. Yeah, no. Go Slob Cats.
Yeah. Nice.
Ethan, I keep thinking that you're a minion when I look over at your screen.
Oh, yeah. My yellow. Yeah.
Yeah, the yellow hat and like the goggles and everything. You were looking down for a minute, so it was just your hat on the screen. And I was like,
yeah.
Freaking minion over here.
Yeah, I gotta show the editing setup. It's like multi-screened chaos right now. So map making right now for the videos, which takes a lot of time. Oh, teaser.
Screenshot that. Write that down.
Yeah, real ones will know what that. I mean, the video is going to come out at the end of next week anyway, so
leak it.
Has to be out by the 19th. Otherwise, Simply Safe is going to be mad at me. So.
Oh, is that this video sponsor?
Yeah, I have all the stuff behind me. I gotta like set it all up soon and film the ad for it.
Have you done Audible yet?
No, I haven't done Audible.
Okay. What about Raid Shadow Legends?
No, they haven't reached out to me. I'm actually doing War Thunder next month, but I'm doing like a naval-oriented video for that one. So
okay,
cool.
Yep.
Do they let you play as the Edmund Fitzgerald in that game? Just out of curiosity.
Well, that video is actually going to be about Typhoon Cobra, which is a infamous storm in World War II that Admiral Halsey sailed 7th Fleet through, and sank like 3 destroyers. Like he sailed through the middle of a Cat 4 typhoon, and it sank several destroyers, killed like 800 U.S. sailors. Like it was like
There's pictures of that, isn't there?
Yeah, there's a lot of like ship damage photos and stuff like that, and there's like a radar scan from like the like a 1940s like eye wall radar shot from an anti-aircraft radar. So
that's awesome.
Yeah.
What about Raycon? I'm just gonna go through the list of every like sponsor that I have.
No, I haven't done Raycon. I've done let me think of the ones. What did I just do last month? I did ground news for the past 2 months. I did
NordVPN. That's another one. Good one, chat.
No, I did not ExpressVPN or one of those. I did a VPN though, not Nord though. What's the other one that I did?
HelloFresh. Chat is just like, dude,
I did Factor.
We touched the nerve. People are really liking us talking about the different sponsors that Ethan's had on his videos. So
Yeah. Wow.
That's awesome.
Yeah.
Honey, didn't Honey have a huge scandal that just happened?
Yeah. I've not been. No, I believe it or not, I do say no to some sponsors. I do have some level of integrity, I'd like to think.
Dude, if I had a YouTube channel where it was just my personal brand and I didn't have anyone else involved that I had to consider, I would be an absolute whore for advertisements. Just throw all of them my way. Like dude, find me whatever
Is
the
that Mark?
shittiest team. What'd you say?
Sorry, I interrupted you. I didn't know Mark was in here.
Yeah, Mark's in here.
Oh, Mark. Oh, Mark.
North PNW representation.
There it is. Oh, Marky Mark.
What was originally a Kyle episode has turned into a surprise guest, Ethan Moriarty.
Oh
So-
yeah, sorry, I didn't mean to hijack.
No,
Kyle.
we were getting ready
I've
to
done this
jump
like
out of
2
here, so-
times now to Kyle, where I
Yeah,
just
no,
hopped
it's
in.
fine.
No, I saw
Oh,
that it was
every
an
time-
afternoon thing, and I've been drawing maps for a good chunk of this morning, and I wanted something to, occupy my brain.
It's been on my agenda to hijack somebody else's, but I'm always doing something at some of these times. So
I mean,
Maybe this
rightfully
week.
so, to be fair.
yeah, maybe this week. Who do we have coming up next, Gabe?
So actually, only on the Discord schedule, we have a group coaching session with Trey this upcoming Thursday at 8 p.m. But we have
Okay.
between office hours, which everybody, just FYI, you're going to see different titles for things. There's office hours, there's group coaching. Office hours is free. It's once a week. It's going to remain free until the end of time or until, something happens to SEC, God forbid. And then group coaching is actually part of the Chaser Academy, that whole 30-day free trial I was talking about earlier. Those are a little more focused. We pick a specific topic. We really drill down into it. We take questions
Yeah, that
around
was
that
fun.
topic. Yeah, it was
I like
a
that.
great time talking about chasecation preparation. And I like too how it was a little different than like a training module, and it was just more of an open, free-flowing conversation. So it wasn't like write a script and make sure you do all the video
Yeah.
editing and stuff. Made it a little easier for people to participate and contribute as well. So that was really cool. But anyways, to answer your question a little more in depth, Kyle, there's only 2 events on the schedule right now. One of them is this office hours episode, and then the upcoming group coaching session with Trey on Thursday. But the lovely B, our COO, shout out to her again. Oh, she's got her hand up. I'm actually going to invite her to speak on the stage. The lovely B has got like 15 office hours and group coaching sessions scheduled coming up here in the future. And I spent all day yesterday. Ethan, I will see you working on maps all day, and I will raise you making 104 promotional graphics. And that was my day yesterday, was literally just sitting in Canva making 1 million promotional graphics for all of you folks. So we've got different sizes and shapes and everything else for each of the coaches now that we can put out on social media. So now that I've got all those made, she can start to load all of these upcoming events into the events tab on the sidebar there for people who are on on Discord to look at and see all the upcoming events. So you'll be able to see like a month to 2 months into the future at any given time.
At least Canva is somewhat intuitive.
Yeah.
QGIS
So I was
is
gonna
not.
say,
B, what's going on?
you guys hear me?
Yes.
So just a heads up for this coming week, we've got Hunter. He's going to be doing a coaching session on Tuesday. So that'll be at 7 p.m. And then Wednesday is kind of up in the air. We have an office hours. We're like in between 2 people. And we're going to have a new host for that too. So that'll be exciting.
Yeah,
I
our
think
junior
Phil
coach,
is
right?
coming on.
Stephen Cross.
Yeah, he'll be junior coaching possibly, but Phil hosting is going to be a new host for the office hours on Wednesday.
Oh yeah, I don't think I announced this. Like, what an idiot I am. I don't think I announced this yet. Phil Johnson, Stormfront Freaks podcast host. Now podcast is retired. I immediately went to work and was like, dude, you got to come do some stuff with Storm Chaser coaching. And he thankfully agreed to help out and jump in and host here and there. So he's going to be doing some of the hosting for these office hours and the group coaching sessions. That way I don't have to do every single one of them.
Then we've got on Thursday night, Trey is going to do a coaching session as well. So you got three things to look forward to next week, and we'll be putting out those advertisements so you guys know when to tune in.
So you said Hunter on Tuesday?
Yeah.
Hunter on Tuesday, new person on Wednesday, and then Trey on Thursday. So you should be able to find someone to stream bomb in there, Kyle, if you're looking for an opportunity.
Okay. Probably won't bomb maybe I will bomb a coaching session. I don't know. The office hours are a little less formal, but yeah, we'll get all the boys to bomb somebody, I'm sure.
All right. Well, B, thank you for coming on here and letting us know about that. Ethan, thank you for gracing us with your presence. Hannah, thank you for being here as the audience coordinator today. You did a fantastic job, and really happy to have you in that role moving forward when Anna isn't able to make it. We got Hannah and Anna, so it gets a little bit confusing. They're both doing the same thing as an audience coordinator. So we'll have to try to keep that straight. And of course, Kyle, thank you for joining us here today.
Yeah, of course. Anytime. These are fun. I like the ability for people to just ask whatever's on their mind and kind of ramble about it. I do have a question though, Ethan. I think your video went out, but I'd like to know how terrible those chocolates are that you're about to eat, because I think that was an advent calendar you just had there.
Yeah, it was. Yeah, I got a squirrel right now.
Squirrel. That's very
From
Christmas.
Trader Joe's.
Yep. What does a squirrel have to do with Christmas? Does it have a Christmas hat? How is it a Christmas squirrel? That's what I want to know.
It was a squirrel.
Hmm.
All right.
Very good.
Right. Goodbye.
Anyway,
Have a good one. See ya.
See you guys.